In the second part of 3.9, we will talk about the derivatives of logarithmic functions. So here are some formulas. The derivative of ln of x is 1 over x. The derivative with respect to x of ln of u is 1 over u times u prime. Remember that u prime because we have a u term with an input of x. The derivative of log base a of x is going to be 1 over ln ax. And the derivative of log base a of u is 1 over ln au times u prime. We always get that u prime when we have a u term with an x input. Now recall some properties of logarithms. So if you have log of ab, where we're multiplying two terms under the same log, when you expand it, it becomes log of a plus log of b. Same thing for natural log. Log of a divided by b equals to log of a minus, and I'm sorry, this should be log b, not just b. So please correct that in your notes. Ln of a over b is ln of a minus ln b. Log of x to the a. If you have the log of x with an exponent of a, the a comes to the front, becomes a times log of a, and then same thing for natural log. So this should be reviewed from your college algebra or pre-calc class. Now let's differentiate. F of x equals to the natural log of x cubed times x plus 7 to the 9th times x squared plus 8. If we try to use the product rule, it's going to be a nightmare because we're multiplying three different things. So let's say we call this term a and this term b. Then term a has a product rule also. We also have the chain rule because we have these exponents. It's going to be a mess. So when we have a complicated term like this, it's often easier to use the property of natural log, where natural log of ab equals to natural log of a plus natural log of b. Okay, so what we're going to do is we're going to take this and we're going to write that as a sum of three different logs. So first we're going to say that f of x equals to natural log of x cubed plus the natural log of x plus 7 to the 9th plus the natural log of x squared plus 8 to the second power. Now, according to this third property of logarithms that we have here, if you have natural log of x to the a comes to the front. So for natural log of x cubed, the 3 comes to the front, the 9 comes to the front, and the 2 comes to the front. So now we can take the derivative. F prime of x is going to be 3 times 1 over x. Remember, the natural log of x is just 1 over x. The natural log of x over 7 is just 1 over x plus 7. And then we take the derivative of x plus 7, but that's just equal to 1, so we don't have to write the 1. And then the derivative of natural log of x squared plus 8, according to this formula over here, it's going to be 1 over u times u prime. So our u term in this case is the x squared plus 8. So it'll be 1 over x squared plus 8. But whenever the parenthesis contains any other function than x, we have to take its derivative, which will be 2x by the chain rule. And then if you multiply 2 times 2x, that's going to give you 4x. Okay, next example, we want to differentiate f of x equals to 4x minus 3 cubed times 3x squared plus 10 to the 5th using and I'm going to sneak in a g in there, using logarithmic differentiation. Do not use a product rule because I think it'll just be a little bit harder. So before we can use logarithmic differentiation, we have to introduce a log into the function. Now, the difference between this example and the previous one is that in the previous example, we already had a natural log. In this case, we don't. So what we're going to do is we're going to first replace the f of x with the y, and then we take the natural log of both sides. Now, why can we do this? Because as long as you take the natural log of both sides, this is allowed. Again, in the previous example, this wasn't needed because we already had a natural log, whereas here we didn't. So we are going to replace the f of x with the y because f of x and y are the same thing. And then we're going to take the natural log of both sides. Now, once we do this, we can use the property of natural logs where the product of two terms equals to the sum when you split them up into separate natural logs. So we have ln y equals to ln 4x minus 3 cubed plus ln 3x squared plus 10 to the 5th. Okay, so from here, the 3 and the 5 are going to come down since those are exponents. So we get the natural log of y equals to the natural log of 3 plus the natural log of 5 times 3x squared plus 10. Okay? And actually, for proper notation, I'm going to put the natural log inside here, not outside. Okay, so we have 3 times the natural log of 4x minus 3 and 5 times the natural log of 3x squared plus 10. So just this 3 and this 5, they both are going to come down. So then from here, we are going to take the natural log of 4x minus 3 and take its derivative, the natural log of 3x squared plus 10, take its derivative, natural log of y and take its derivative. So the derivative of natural log of y is going to be 1 over y, but we have that dy dx because we have a y term with an x input. Okay? Here, the derivative of 3 times natural log of 4x minus 3. So the 3 is going to be separate. Natural log of 4x minus 3 has a derivative of 1 over 4x minus 3. But because this contains a term that's not just x, we have to take its derivative as well, which is going to be 4. Same thing over here. The 5 is separate. Then we have 1 over 3x squared plus 10 according to this formula, which is natural log of u is 1 over u times u prime. So we have to have u prime, where u is a term that you're taking the natural log of. And the derivative of 3x squared plus 10 is going to be 6x. Then we can simplify this. So 3 times 4 is going to be 12 over 4x minus 3. 5 times 6x is going to be 30x over 3x squared plus 10. Now the thing is, we can't quite stop here because our objective is to get that dy dx by itself, and it's not because you have the 1 over y. So now we're going to multiply both sides by y. Okay, so we get this whole thing, 12 over 4x minus 3 plus 30x over 3x squared plus 10. That whole thing gets multiplied by y, so the dy dx could be by itself. But we don't want something in terms of y. We want everything in terms of x. So from the original function, y equals to 4x minus 3 cubed and 3x squared plus 10 to the 5th. So I'm going to replace the y with 4x minus 3 cubed times 3x squared minus 10 to the 5th. So this here is going to be your y, and then you have that bracket from the previous step. Okay, next example, let's differentiate natural log of the square root of 8x minus 6 times 9 over divided by 9x plus 3. So first off, remember that anytime we have a square root, we have to write that to the power of 1/2. So we're going to get f of x equals to natural log of 8x minus 6 to the 1/2. Now, because we're dividing these two terms, division leads to subtraction when you write them as two separate logarithms. So we have natural log of 8x minus 6 to the 1/2 minus the natural log of 9x plus 3 to the 1/2. Okay, so remember, square root is going to be 1/2 in exponential form. It's the second root and the exponent's 1. So remember, it's the second root, which is why we have a square root. Then the 1/2 comes to the front, so we have f of x equals to 1/2 times the natural log of 8x minus 6 minus 1/2 times the natural log of 9x plus 3. And now from here, we just use the derivative of the natural log. So the derivative is going to be, so your 1/2 is going to stay the way it is. We have 1 over 8x minus 6, but since the parentheses contains another function that's not x, we have to multiply by its derivative, which is 8. Then you have 1 over 9x plus 3 by the same reasoning times 9. Derivative of 9x plus 3 is 9. Then if you combine that, it's going to give you 4 over 8x minus 6 minus 9 over 2 times 9x plus 3. And in this case, no need to multiply by y because the left side, it didn't have the 1 over y since we already had a natural log, whereas the previous example did not. Okay, next we want to use logarithmic differentiation to find the derivative. Now in this case, see how this problem is different than the previous one. The previous problem, we already had a natural log. In this problem, we don't. So what we're going to do is, we're first going to replace the f of x with y. We're going to say y equals to x to the 4th times x minus 4 to the 5th over x squared plus 7 to the 4th. And then to introduce a logarithm, we take the natural log of each side. So we have natural log of f of x, which is the same thing as y. equals to natural log of x to the fourth minus times x minus 4 to the fifth over x squared plus 7 to the fourth, which is that whole thing. Now, remember that anytime you multiply two things, they're going to turn into addition. And if you divide, it's going to turn into subtraction. So when I rewrite this, I'm going to get the natural log of y. So remember, replace f of x with y equals to natural log of x to the fourth plus the natural log of x minus 4 to the fifth. But since we're dividing this bottom term, it's going to be minus the natural log of x squared plus 7 to the fourth. Now we're almost ready to take the derivative because all the exponents have to come to the front. So we have the natural log of y equals to 4 ln x plus 5 ln x minus 4 minus 4 ln of x squared plus 7. Now if I take the derivative of all these terms, the derivative of y, ln y with respect to x, is going to be 1 over y, but then we have that dy dx because we have a y term with an x input. Here we have 4 times 1 over x. Here we have 5 times 1 over x minus 4. If you multiply by the derivative of this, it's just going to be 1, so we don't have to write anything. And then you have 4 times 1 over x squared plus 7 times 2x, because the derivative of x squared is going to be 2x. And then this is going to give you 1 over y dy dx equals to 4 over x plus 5 over x minus 4 minus 4 times 2x, which is 8x over x squared plus 7. And then you want to get that dy dx by itself, so we multiply everything by y. And we can't leave our answer like this because we don't want a y term with x's. So since y is equal to this original term, we're going to replace the y with that original term, and this becomes our answer. I just wrote the y at the front because that's what we usually do. Now imagine if you try to differentiate this without logarithmic differentiation, it'd be a mess. You would have the chain rule, the product rule, the quotient rule, all of that in one. So this makes it a lot easier. All right, and that's it for this lesson. Please come to class prepared with questions. Thank you.